Section 1.6, combining functions and composite functions. So I'm sure you've seen this before at some point. We are going to be talking about how to add, subtract, multiply, and divide some functions. These definitions work exactly the way you would like for them to. If you see f plus g of x, that means f of x plus g of x. F minus g of x is f of x minus g of x. If you see fg of x, it's f of x times g of x. Sometimes you'll see the fg in parentheses. Sometimes you will see the dot written between them. It's all the same. And then for quotient, you have f over g of x, which is f of x over g of x, as long as g of x is not 0, because we're never allowed to have 0 in a denominator. And just like on the product, you'll sometimes see the f over g written in parentheses. Okay, now the domain of these new functions consists of all the values of x that are common to both domains. So the numbers we plug in have to be good in f and also be good in g. Now, f over g, it adds one level. We do have to make sure that g of x is not 0. But still, we're not allowed to use anything that is not in the domain of f or g. So let's just work a couple of example problems. For the given functions f and g, find each of the following and state its domain. So f plus g, f minus g, f times g, f over g, and then g over f, because they are different. So let's do part A. F plus g. Well, this is f of x plus g of x, which will be 2x minus 1, that's f of x, plus g of x, which is x squared. Now, we usually don't write it in this order. You're going to see it more likely written in descending power order. Okay? So this is what you would get when you add them together. Now let's talk about the domain. We need to talk about anything that has to be excluded from f or that needs to be excluded from g. So what's the domain of 2x minus 1? That's a linear equation. There are no roots in it. There is no denominator to it. So the domain of f is going to be negative infinity to positive infinity. Same thing here with g. X squared is defined everywhere on the x. So this is negative infinity to positive infinity. Now, since the two pieces we were using were good from infinity to infinity, and we have not added any new complications when we combine them, this will have the same domain. Part B, f minus g. So this would be f of x minus g of x. So you need to be careful with your parentheses here, just to make sure that when you're subtracting, of course, you have to be careful because you might end up needing to distribute the negative. So f of x is 2x minus 1. G of x is x squared. I would use parentheses here if I needed to. And again, we normally write the square term first, so just rearrange this. Negative x squared plus 2x minus 1. And again, our two pieces that we used both have no restrictions on the domain. There are no new complications in here, no roots, no denominators. So the domain on this one is still negative infinity to positive infinity. Okay. C, f times g. So this would be f of x times g of x. So this would be x squared times 2x minus 1, because of course when it's multiplication you can write it in either order. Now the book and the computer will want you to distribute here to get 2x cubed minus x squared. There are no new complications on our domain, so our domain is still negative infinity to positive infinity. Part D, f over g. So that's f of x over g of x, which is 2x minus 1 over x squared. I would simplify it if I could, but nothing really simplifies here. So now we just need to be aware of our domain. We do have a denominator here, so we're going to have to exclude anything that makes that 0. And in this case, 0 makes that 0. So x cannot equal 0. So the domain will be negative infinity up to 0, not including 0, union not including 0 to positive infinity. We just punched out the 0. It's no longer included in the domain. Now part E is g over f. So g of x over f of x will be x squared over 2x minus 1. And we still had no problems with each individual piece, but we do have to be aware of what makes that 0. And so x cannot equal, if I plug in positive 1/2, that's where I get 0. So x cannot equal positive 1/2, which means our domain is negative infinity up to 1/2, not including 1/2, union 1/2 to infinity.